name, and I'm going to add end line like this. Okay, so this is the way to pass a parameter, so to pass a value to your function. And as I said in my previous video, you can really separate this declaration and definition of a function. So you can put really declaration of your function here, so before your main function, and then you can put definition of your function after your main function. And if you don't know how to do that, make sure to watch my first video of this playlist. Okay, so now I want to invoke this function here. And how we do that? Well, we specify the name of my function. So I'm going to say introduce me, and then since this function receives argument, so since this function receives a parameter here, we really have to pass that parameter to our function, and that I'm going to put here. So here I'm going to pass an argument to my function. So I'm going to say Saldina like this, and this here really is called argument, so it is a value that we pass to our function, and then here it is called parameter. Okay, so now if I run my program, you can see that my function has successfully introduced me. So it says my name is Saldina like this. Okay, so here we have really defined our function. So the parameters that our function receives, name, return type, and then the block of code that our function is going to execute. And then here we have invoked our function and passed an argument, which is this string of text here, to our function, which is going to be received in this name variable. And then our function is going to really treat it as a variable, which means that it is going to write that value here. Okay, and now if I try to invoke this function once more, so I'm going to copy this line and then paste it here, and let's say that I'm going to pass it a different value. So I'm going to say, for example, Anna. Okay, you can see that now our function has successfully introduced two users. So it has said my name is Saldina, and then my name is Anna. And there is also another thing that I want to explain, and that is going to be how you can pass multiple arguments to your function, and that is going to be in a following way. So here in these parentheses where I have specified my first parameter, you can put comma sign, and then you specify your second, third, fourth, fifth, and your other parameters. So you specify the type, which is also going to be string in this particular case. And let's say that my second parameter is going to be called city, like this. And let's add another one. So let's say int age, like this. So now in this function, I'm going to write out also where is my user from, and also how old my user is. So I'm going to write out cout, I am from, and then let's write out this city that we have passed in this function, and add also end line. And let's write out also I am age, so I am however many years we have passed in this function, and then let's say years old, like this. Okay, so now we have really introduced our user in more detail, and we have passed to this function name, city, and age information for our user. But as you can see here, our function, so our compiler really says that this function is not valid. It has too few arguments in a function call, meaning that this invocation, this call of a function, does not really contain all the necessary parameters or all the necessary arguments that we need to pass to our function, which means that it really lacks the city and age parameters. So here I'm going to put comma as well, and then I'm going to specify my city. This here is bolded, so it is bold, and that means that we have to really pass a city value to our function. So I'm going to write out Mostar like this, and then I am also going to specify age. So I'm going to say 25. And let's do the same for our Anna user. So I'm going to say that our Anna is from New York, and let's say that she has 27 years old, for example. So now when I run my program, you can see that we have successfully introduced two users. So my name is Saldina, I am from Mostar, I am 25 years old, and then also my name is Anna, I am from New York, and I am 27 years old. Okay, so, and we have really written this code only once, and then we can reuse it however many times we need to. So in this particular case, we have used it 2 times. Okay, and another thing that I want to explain is going to be a default parameter. So what is default parameter? Sometimes you really don't want to pass a value to your function, meaning that in a specific situation you don't have that value or you don't want to pass it, and in that case you want to define default value for your parameter. So in the case where your user does not pass that argument to your function, for example, you can say that your age parameter here has the default value of 0, okay, and that means that you don't really have to pass this age parameter anymore. So here I'm going to delete this age for my Anna user. And let's run our program now in order to see how this function is going to behave for this first user, and then also to see how it is going to behave for this second user which did not specify this age parameter, so this age argument. And when I run it, you can see that my first user has been introduced as it was previously, so I am 25 years old, and then the second user, which did not specify age argument, it really said I am 0 years old, meaning that our function has really taken this default value and it has written out I am and then this default value and then years old. Oh, we are missing S here. Okay, so I'm going to add S, and I want to do a following thing. So in the case where our user does not pass this value for our age parameter, I'm going to really check whether we have that value or we have this default value. And then in the case where we have only this default value, I don't want to write this line of code here. So I am going to say here, if age is not equal to 0, meaning that our user has specified some other value which is not 0, then and only then we are going to write this line of code. But in the case where we have only this default value, we do not really want to write out that our user has 0 years old, because that does not make sense. Okay, so as you can see now, my first user has been introduced as I am 25 years old, and then my name is Anna, I am from New York. Since Anna did not specify how old she is, we haven't written out her age here because of this check that we have added. Okay, so that was about default parameter, and there is one thing also that I want to say about this default parameter, and that is going to be really, if I delete this is equal to 0 and then I try to assign default value to this city parameter, so I say, let's say that city is equal to default, like this, you can see that the compiler is really underlying this function, and it says, okay, it says default argument not at end of parameter list, meaning that you can specify default argument only at the end of this list. So if you want to specify default value for this parameter, you will have to specify default value for this one as well. So if I add default value here, so I have added 0, then we can really add a default value for this second parameter, and then we can add default value for this one as well. And now we are really left with, so our compiler is not underlying this introduce me function name anymore. Okay, and this does not make sense, so I'm going to delete it, but I wanted to explain that you cannot specify default value for your middle parameter if you did not specify a default value at the end of your parameters list. And there is one more thing that I want to show you, and that is going to be that you don't have to hard code these values as we did here. So I'm going to comment these out, and then I'm going to let my user define his own values for these three variables. So I am going to declare two variables of type string, which are going to be name and city. And then also I'm going to declare a variable of type int, which is going to be called age. And then I'm going to say cout, so please enter a name like this. It's not capital letter, okay. And then cin name, and then cout city. So after my user has entered name, I want him to enter city. So cin city, like this. And then also I want to enter age and cin age, like this. So now, after my user has specified these three variables, so name, city, and age, I can pass these three in my introduce me function. So I can say introduce me and then pass name and city and age, like this. And if I run my program now, as you can see, my program really asks me to enter a name. So let's say that name is going to be Tom, for example. And then let's say that city is going to be London. And age, let's say 32. Okay. And now, as you can see, my function has successfully introduced Tom. So it says, my name is Tom, I am from London, and I am 32 years old. Okay. And you don't really have to use these names for the variables in your main function. So the names of these variables here do not have to be the same as these names here. So you can call these, for example, name 1, city 1, age 1, but you are going to have to use these names in your main function. So you will have to say name 1, city 1, age 1, and here as well. But these names do not have to be the same as these names here. Your program is going to work correctly. You have to, however, have the same type here and here. So this here has to be string if it has been declared as string here, and this one as well. And then age also has to be of type int if it has been declared as int here. And once more, if I run my program, you can see that it asks for name, so Tom, New York, and then age is going to be 22. And as you can see, my name is Tom, I'm from New York, I am 22 years old. So your program works just fine. So I hope that you have understood how parameters behave in a function and how you can pass multiple parameters to your function, and also how you can specify a default parameter in your function. And if you enjoyed this video, if you learned something new, make sure to subscribe to my channel, click the bell icon so that you are notified when I publish my next video. Also like it and share it with your friends. And follow me on my other social media, so Instagram and Twitter accounts, True Code Beauty. Thanks for watching, and I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ functions. In this video, I wanted to talk about return statements and return types of a function. So what is return type of a function? Well, return type of a function can be any data type that can be used in order to declare a variable. So it can be int, float, bool, char, double. It can be any user-created data type, and it can be void as well, which means that that function is not going to return anything. And as we explained in one of my previous videos, function is a block of code. It is a code that is grouped together, and that code is going to perform a specific task. And here I want to make a difference between functions that return value and functions that don't return value. And functions that don't return value can be, for example, an example of a function that does not return value can be a function that writes out a menu to your user. So you call that function writes out a menu to your user, and the job of that function is done there. So you are not expecting any value to be returned from that function. But an example of a function that returns a value can be a function that performs a specific calculation, let's say on arguments that you pass to that function, and after that calculation is performed, you are expecting a certain value, so result of that calculation, to be returned from that function. And an important thing is that function can return only one value. So only one return statement inside your function is going to be executed. And I'm going to show that on the example that we are going to do in this video. And now I'm going to show you really how functions make your code easier to read, easier to understand, and how they make your code reusable. So we are going to show that on an example, which we are going to first make without using a function. So we are going to make a program that is going to determine whether a number is prime number or not, and we are going to do that first without using functions, and then I'm going to refactor that program so that it uses functions, and then I'm going to show you how that program becomes instantly more readable, more understandable, and also how that makes your code reusable. So as I said, we are going to create a program that is going to determine whether our number is prime number or not. And the definition of a prime number is a number that is divisible only by itself and by 1. So if that number is divisible by any other number, so not 1 and not itself, but any other number, that means that that number is not prime number. So the first thing that I'm going to do here is I'm going to declare a variable of type int, call it number, and then I'm going to let my user enter that number. So I'm going to write out the message to my user and then use the cin command in order to get that number and store it in my number variable. And then let's explain the algorithm that we are going to use in order to determine whether that number is prime number or not. The definition of a prime number is a number that is divisible only by 1 and by itself, which means that if you can find any other number besides 1 and that number itself that you can use to divide it by this number that our user has entered and get the remainder of 0, that means that this number is not prime number. So how we are going to solve this problem? Well, we are going to iterate through all the numbers between 2 and this number minus 1, and then we are going to check whether this number is divisible by that counter value. So I'm going to write out for int I is equal to 2, and then I is less than number, and in each iteration I want to increase the value of my I counter. So why haven't I used 1 here, and why haven't I said here that this I is less than or equal to the number? Because every number can be divided by 1, so we do not need really to check that. And also every number can be divided by itself, and we do not need to check that as well. So here we are going to iterate through this interval, so between 2 and while I is less than that number that our user has entered. And here we are going to check whether this number that our user has entered can be divided by any value of our I, so in any iteration which we are going to go through. And in the situation where it can be divided, we are going to use a flag, which I'm going to declare here. And that flag is going to be of type bool, and let's call it is prime flag, like this, okay? And this flag is initially going to be assigned a value of true. So we are going to initially say that all the numbers are prime numbers, and then we want to prove that wrong for the numbers that are not. So we are going to use this flag in a following way. Here I'm going to check in each iteration if our number that our user has entered can be divided by that current counter, so by the current value of I. So I'm going to use this modulo operation, and I'm going to say if this number modulated by I is going to give us the result of 0, so when you divide this number by I, do you get the remainder of 0? And if this operation here results as true, we are going to say that our is prime flag is going to be false. So we are going to assign the false value to our is prime flag because we have clearly found one number which is not 1 and that number itself that can be used in order to make this condition true. So here I'm going to write out is prime flag, and then I'm going to assign it a value of false. And then another thing is going to be really if we find one number, so even one number is enough to find that really fulfills this condition here in order to say that our number is not prime number. And in that situation, we do not really need to check any more numbers because we have determined that our number is not prime number. So here I can use break statement. So I can say, if you find only one number, please do not iterate through this for loop anymore because we do not need to find any more numbers. So in this situation here, we have iterated through all the numbers between 2 and that number that our user has entered. We have checked whether that number can be divided by any value of our I counter. And if it can be divided, meaning that it gives the remainder of 0 after that division, we are going to set our prime flag to false and we are going to break from our for loop. And after we have successfully fulfilled this, so after we have successfully iterated through this for loop, or we have fulfilled this condition in one iteration, we are going to leave our for loop and we are going to come to this line of code here. And here I want to check what has happened with my is prime flag, meaning I want to check whether this is prime flag has stayed true, which means that our for loop has executed all of its iterations and it has not found any number that can be really used to fulfill this condition here. And in that particular situation, that flag is going to stay true, and that is going to mean that our number is prime number. So here I'm going to write out if is prime flag, meaning if this value here, if this variable here holds the value of true, we are going to write out cout like this, and we are going to write out prime number like this. Okay, and let's also add end line here. But in a situation where this here does not hold a value of true, that means that in one iteration, so it can be the first one, it can be the last one, it can be any in between, we have really found at least one number that can be used to fulfill this condition and that has set our is prime flag to false. And in that situation, we are going to use our else statement, and we are going to copy this and we are going to really modify it to say not prime number like this. Okay, so now if I run this program, you can see that it asks us to enter a number. I'm going to enter a number, let's say 5, for example, and it says that 5 is prime number, which is correct. 5 is a prime number. And let's run it one more time. And let's say that we want to check 6 this time. And as you can see, our program has written out that 6 is not prime number. And 6 really is not prime number because it is divisible by 2 and by 3, besides from 1 and itself. Okay. So now you have seen how we can really solve this problem. And let's try to refactor this program here in order to use functions. So how we are going to do that? Well, the first thing that we need to do is we need to create a function, and I'm going to do that here. And since this part of code here, this is the part of code that we are going to move to our function, and since this part of code here determines really whether our number is prime number or not, and then sets this flag to true or false, let's say that we are going to create a function which is going to check as well whether the number is prime number or not, and then it is going to return a value true or false, meaning the number is prime number or the number is not prime number, and that we are going to write here. So here I'm going to put the return type of my function, and that is going to be bool. So that is the return type of my function, and then the name for my function is going to be is prime number like this. And then let's say that we want to pass an argument to that function, and that argument is going to be of type int, and that argument is going to be really the number that we want to, the number that we want to check. So we are going to pass the number to our function. That function is going to, in this body here, check whether that number is prime number or not, and then it is going to return bool value, meaning true or false. So if the number is prime number, it is going to return true, and if the number is not prime number, it is going to return the value of false. And how we are going to do that? Very simple. So you see this code here. I'm going to comment this code here, and I'm going to really, no, I should have copied it before. So I'm going to copy this code here, and I'm going to move it to my function. Okay, and we have previously explained this code here, so we do not need to explain it again. But what I'm going to say here is, after this algorithm is done, so after we have really stored the value of true or false, so we have stored the value of false in our isPrime flag, or we have really kept this true value inside our isPrime flag, what we need to do is we really just need to say return isPrime flag, like this. So after we have checked whether our number is prime or not, we can really just return that value from our function. Okay, so we can now, after we have moved this code to our function, we can delete it from here, like this. Okay, and then as you can see, we have been left with this isPrime flag, which is not declared now. So identifier isPrime flag is undefined, meaning that now we have to really declare it, and we have to assign it a value. So I'm going to say here, bool is prime flag, like this, and then the value that I'm going to assign to my isPrime flag variable is going to be whatever value our function returns. So here I'm going to say, please call my function isPrime number. Oh, isPrime number, like this. Okay, and then pass to that function this argument here. So our function expects a value, and that is going to be this number that we want to check whether it's prime or not. And then after this function here is done, it is going to return a value of either true or false, and that value is going to be stored inside our isPrime flag variable. Okay, so now if I run my program, you can see that it asks us again to enter a number. So I'm going to say, let's check number 9, for example, and it says that number 9 is not prime number, which is not, because it is divisible by 3. And let's check number 13, for example, and 13 is prime number. Okay, so after we have really used this function in order to perform this particular task, I want to show you one more thing, and that is going to be how we can refactor this function here in order to make it even more simple. And if you look at this function here, you can see that this isPrime flag is set to true here, and then in this situation where we find number that can be used to fulfill this condition here, we set that isPrime flag to false, and then we use this break statement in order to break our for loop. So we are not going to iterate anymore through our for loop when we come to this break statement. And then we really go here, and then we return that isPrime flag. But we can do that in a more simple manner, and that is going to be really here. So here, in a situation where we find number that is really fulfilling this condition here, we can say, at this very line of code, we can say return false, like this, because this code here we can delete. And why I can use this return statement? Because this return statement is going to really break our for loop, and it is going to return the value from our isPrime number function, meaning it is going to do two things. So we do not really need to set the flag and then return the value of that flag at the end, but we can really say, if you find any number that can fulfill this condition, return false immediately. So break for loop and also return the value from our function, meaning end the execution of that function, because we have found our result. And then here as well, we do not really need to declare this isPrime flag to true and then return it because it is clearly true. So we can say here, return true, and then remove this flag from here, like this. And then as well, I can remove these curly brackets and make my code even more readable. So now I want to explain what we have done. So here we are passing a number to our isPrimeNumber function. Then we are iterating through all the numbers between 2 and that number. We have skipped 1 and that number itself because all the numbers are divisible by 1 and by that number itself. And then we are checking whether any of these I values between 2 and number fulfill this condition here. That would mean that that number is divisible by that current value of I, and that would mean that our number is not prime number. So at that very moment we can say, please return false, because this number is clearly not prime number. But in a situation where this for loop has really iterated through all of its iterations and it has not found any number that fulfills this condition here, that means that this return false statement has not been executed. And then in that particular situation, this return statement here is going to be executed, and this return statement here says return true. Okay, so this part of code here has not changed, nor it is going to change. And if I run it again, you can see it asks me to enter a number. I'm going to enter number 7. Then it is going to check whether that number is prime number. So it is going to call our function and assign the result of that to our isPrime flag variable. And I press enter here. You can see that we get the result prime number because 7 is prime number. Okay, and that is really making your code much more readable and reusable as well. So this main function here is much more clean than it was before. And now I want to show you the most beautiful thing, and that is going to be how we can make this isPrimeNumber function reusable. So let's say that I am going to delete all of this code here. So I'm going to delete it. And now I know that I have written out this isPrimeNumber function, and I know that I can really invoke this function and use it whenever I need to determine whether some number is prime number or not. So let's say that now we want to check all the prime numbers between 1 and 1,000, for example. So how we are going to do that? Well, we are going to iterate through all the numbers between 1, so I is equal to 1, and then I is less than or equal to 1,000, and increase our I in each iteration by 1, like this. And then in each iteration, I really am going to just send this I to my function, and I'm going to really get the result from this function. So this function is going to tell me whether that I is prime number or not. So here I'm going to declare a variable of type bool, and I'm going to call it is prime, and I'm going to assign to that variable a value of is prime number when I pass it the value of I. So whatever this function here returns, whatever this function here results in, I'm going to assign that result to my isPrime variable. Okay, and now what I want to write out is all the numbers that are prime numbers between 1 and this 1,000 value. So I'm going to say if is prime, like this. I'm going to write out cout, and then I want to write out the current value of my I counter because that is a number that we are talking about. So I is prime number, like this. Okay, and I'm going to add a new line at the end. So this code here is really going to check all the prime numbers between 1 and 1,000, and it is going to write out all the prime numbers in that interval. And for solving this particular problem, so whether the number is prime number or not, we have used this isPrimeNumber function, which we have written once, and we have really tested it once. We know that it works as it should, and now we can really close it. We do not need to really think about how we are going to perform this task, never again. So we have written it, we have tested it, and now we have this algorithm stored in our isPrimeNumber function, and we know that this function works in a following way. So we pass it a value, and then this function returns us true or false variable, meaning that the number is prime number or not. So once more, if I run my program, you can see that we have gotten the expected result. So we have gotten all the prime numbers between 1 and 1,000, okay? And there are a lot of numbers, okay? So you can check these numbers on your calculator if you want. And let's say now that we really want to check all the numbers between not just 1 and 1,000, but let's say 1 and 10,000 or 100,000, okay? We can call just this isPrimeNumber function, pass it the value of our I, and then check the value that this function has returned. And this function has really told us whether the number is prime number or not, and if the number is prime number, we just want to write that number out to our user. So if I run this function again, you can see that it is writing out all the prime numbers between 1 and 100,000, and there is a lot of numbers again. So you can even count how many prime numbers there are in this interval, so between 1 and 100,000. And let's say that I'm going to leave that part to you. So if you want to really upgrade this program so that it counts how many prime numbers there are in this interval, you can write that code in the comments down below, and I'm going to check it, and as well you can leave it for other people to see and use if they need it. So I hope that you have understood this return type of a function. And in this particular situation, it was bool type, but you can have as a return type from your function, you can have any other data type. So you can have float, char, int, string, whichever data type you can really use in order to create a variable. You can use that data type in order to be a return type of your function. So in this particular situation, I wanted to show you an example of a bit of a more complex function, let's say, that is going to determine whether your number is prime number or not, and it is going to really receive that number that you want to check as an argument, as parameter, and then it is going to return only true or false, meaning that number is prime number or that number is not prime number. And once you have written this code and once you have tested it, you do not really need to bother with this function anymore. You do not need to remember this code, nor read it, nor even understand it in order to use this function. Only in a situation where you have a bug, and that bug is in this particular function, only in that situation you are going to need to really reread this function and fix that bug. In any other situation, you can really just use this isPrimeNumber function. And as well, we could have made other functions with other return types. We could have created, for example, a function that is going to sum two numbers. So you are going to pass to a function two numbers, let's say number A and number B, which your user enters. And then that function is going to sum those two numbers, and it is going to return the result to your main function from where you are going to invoke that function. And as well, I can leave that to you, so you can really practice writing functions on that example, for example, and you can put the code for that exercise in the comments down below as well, and I'm going to check it. And in this particular example, as I said, I wanted to show you a bit more complex example so that you can really understand why we need functions and why they make our code understandable and reusable. And if someone else comes to your code now and he sees that he has isPrimeNumber function, he does not really need to open this function and read how this function works. It is pretty clear from this declaration itself that this function receives a number and determines whether that number is prime number or not, and returns that true or false back to the invoker, back to the function that invoked this isPrimeNumber. Okay, so I hope that you liked this video. I hope that you enjoyed watching this video. If you did, make sure to like it and also subscribe to my channel and follow me on my other social media, so Instagram, Twitter account @TrueCodeBeauty. The link is going to be in the description, and I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another C++ functions video. And in this video I want to talk about a concept that is related to functions, which is function overloading. So I want to first explain what function overloading is. It means that you can create multiple functions with the same name, but those functions are going to have different parameters. So here I have opened my Visual Studio, and let's create a function which is going to be called, for example, sum, and I'm going to put the return type of that function to be int, so integer. If you're not familiar with function return types, I'm going to link that video here, so make sure to watch it. So first thing, we write the return type of our function, and then we write the name of our function, and as I said, our function is going to be called sum. And then I want to pass parameters to this function, so I really want to declare which parameters this function is going to receive, and those are going to be two parameters. The first one is going to be integer, and I'm going to call it a, and then the second one is also going to be integer, and I'm going to call it b, like this. So this is going to be our first function, and let's also say that we want to create another function, which is also going to be called sum, but this time it is going to be of return type double, like this, and then I'm going to call it sum, as I already said, and this function is going to receive two parameters as well, but those are going to be of type double. So I'm going to say double a and then double b, like this. Okay, and as you can see, these functions are underlined because it says function definition for sum not found, meaning we have declared our functions here, but these functions are missing the definition. So definition is missing for this function and then this function as well. And let's also create one more function. So I'm going to say, for example, float, and then I'm also going to call it sum. And let's say that this time I'm going to give it three parameters. So I'm going to say float, let's say float a, and then float b, and then float c, like this. Okay, and then what I want to do is I want to create definitions for these functions, which I'm going to do here. So the first one that I want to define is going to be this one here. So I'm going to copy its declaration, and then I'm going to add these curly brackets, and here I'm going to put a definition for this function. So let's say that I'm going to create a variable of type int, and I'm going to call that variable result, like this, and I'm going to assign it the result of a plus b, like this. And then what I want to do is return this result from my function. So here I'm going to say return result, like this. So this would be one way of returning the result from your function, and then another way to do the same thing is going to be to say really return here. So instead of creating a variable that is going to hold this result, you can really return this result itself from your function. So you can say here return a plus b, and now we can delete this line, and as you can see, this function became shorter and more readable. So now I want to define this function here, so I'm going to say double, okay, I should have copied this, and then double b as well, like this. So here I want to put the definition for this function here, and this function, oh, I'm missing the name for my function. It is called sum. So this is return type, this is the name of our function, and then these are parameters of our function. And here I want to say return a plus b as well, but this time our a and our b are going to be of type double. So in this situation there were integers, and then in this situation there are decimal numbers. Okay, and let's also create a definition for this function here, so this float function, and this time I'm going to copy it. Okay, and I'm going to add these curly brackets, and here I want to write return and then a plus b plus c, like this. Okay, so now how we are going to test this, we can call these functions, we can invoke these functions here in our main function, and the first one that I want to invoke is going to be our int function. So I'm going to say cout, and then this line of code is going to really write out whatever our function returns. So I'm going to say please write out whatever my sum function returns, and then I want to pass to my sum function two numbers. And those two numbers are going to be two integers. And as you can see here, we have really help from our IntelliSense, which says you have three possible functions that you can call. So you have overloaded three functions, and you can navigate through these using your arrows. So the first one is going to be our function that has float return type, and that function receives three parameters of type float. And then the second one is going to be the one that has return type double, and that function receives two double parameters. And then the third one is going to be the one that returns integer, and that function receives two integer values. So here I want to call our integer function, and I want to pass to that function 4 and 3, for example. And let's also add end line like this. And now if I run my program, we can expect to see the result of this line of code here. And as you can see, the result is 7, meaning that our function has been invoked, and then this line of code has received the result of summing these two numbers, and that has been written out in our console, and the result of summing 4 and 3 is 7. Okay, so now I'm going to stop this console, and I want to test these other two functions. So I'm going to say cout, and let's test our sum function that receives two double parameters. So it is going to be this one here. So I'm going to say 4.4 and then 3.3, for example, and I'm going to add end line at the end as well. Okay, and now if I run this program, you can see that our second line is 7.7, meaning 4.4 plus 3.3 is going to be 7.7, which is correct. So we have successfully tested this function here, so this double function that returns double and receives also two double parameters. And then let's also test this third function. So here I want to say cout sum, and then here I want to pass three parameters. The first one is going to be, let's say, 4.4, and then the second one is going to be 3.3, and then 3 decimal point 3.3, and then the third one is going to be 2.2, for example. Okay, now this invocation should invoke this float function. So when I run my program, as you can see here, this third line contains the result of summing these three numbers, and you can check this out using a calculator, but this is the correct result. So as I already explained, this represents function overloading, and we have created three functions. The first one is the one that receives int types and returns int type as well. Then the second one receives double, so two double variables, two double parameters, and returns double as well. And then the third one really contains three arguments, so three parameters, but it has the same name as these previous two. And then it returns float type as well. And then now when we invoke those functions, we can really pass different data types, and depending on those data types, we are going to call adequate functions. So in this first line, we are going to invoke this, and then in this second line, we are going to invoke this, and then in our third line, we are going to invoke this. Okay, so I hope that you understood what function overloading is, and also I hope that you have understood that you don't have to create functions with different names when they are doing almost the same thing. So these three functions, these three are doing the same thing. They are summing the numbers that we pass to them. Only in this particular situation, the first one is summing integers, the second one is summing decimal point numbers, and then this third one really sums three numbers. And we have overloaded this sum function, and we didn't have to create functions that are, for example, sum int and then sum double, and then sum float like this. So we didn't have to name these like sum int, sum double, and sum float, but we can use the same name as long as we have different parameters, different number of parameters, different return type, or something similar. in that particular situation, our compiler is going to decide on its own which function it should call. I hope that you have understood what function overloading is and how you can use that. Thanks for watching, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos. So if that is something that is of interest to you, consider subscribing to my channel and give this video a thumbs up as well. Now in this video, I want to show you how you can build an ATM application. And the first thing that I want to do in order to build this application is going to be to plan the functionalities that this application is going to have. So I'm going to put a comment here, and then here we are going to write all the functionalities that our ATM is going to have. So the first one is going to be to check the balance. So I'm going to write that. So check balance. And then another functionality is going to be to deposit money. So let's say deposit like this. Okay. And then what else? Well, we should be able to withdraw money as well. So let's write that. Okay. And I definitely want to show the menu to my user. So I'm going to write that as well. So I'm going to say show menu like this. Okay. Now, after we have written these functionalities that we want to implement, the first one that I want to implement is going to be this show menu function. So I'm going to put the code for this show menu functionality in a function, and let's create that function here. So I'm going to say void. It is going to be of void return type. Let's call it show menu like this. Oh, like this. Okay. And then what I want to do here is I want to write out the menu to my user. So I'm going to say cout, and then let's add these star symbols. 4, 5, 6, 7, 8, 9, 10. That is going to be enough. Like this. And then I'm going to copy this on the other side so that it looks proportional. Okay. And then the first option that I want to write out to my user is going to be, let's add first, and then check balance. So that is going to be the first option that our user can choose. And then let's add a couple more of these. So the second option is going to be deposit. So I'm going to write that like this. And then the third option is going to be to withdraw. So I'm going to copy this here and then paste it here. Okay, and then let's add these star symbols at the end of our menu like this. Okay, now after we have created this show menu function, what I want to do is I want to invoke this function. So here I'm going to say show menu like this. Okay, and if I run my program, as you can see, we have this menu shown to our user. Now, what should happen next is we should allow our user to choose one of these three options. So the next thing that I will do is I will create a variable. So let's create it here. Let's say int, and that variable is going to store the option that our user chooses. So I'm going to call it option like this. And then here, after I have written out this menu, so this menu here to my user, I'm going to say cout, and then please choose an option or whatever message you want to show. So option like this. And then I want to accept the value that my user enters in this option variable. So I'm going to say cin option like this. Okay. Now, if I run this program again, as you can see, it asks for option, and if I select any of these three options, if I press 3, for example, you can see that my program closes because we haven't written any code after this line here. So what I want to do now is I want to handle these three options. and I'm going to handle these three options using a switch case. So I'm going to write switch, okay, and then here I want to put this option variable. So that is going to be the value that I want to check. So I'm going to say switch option, and then in the case that our user has entered option 1, what I want to do is I want to write out the balance to my user. And in order to do that, I'm going to create a balance variable because we do not have a balance variable yet. So I'm going to give it a type double like this and call it balance. Okay, and let's assign it initial value of, for example, 500. Okay, so that is going to be the initial value of our balance variable. So here I'm going to say cout, and then let's say balance is, okay, and then let's write out this balance variable, and I'm going to add this dollar symbol at the end, and I'm going to add end line as well. Okay, so that is going to happen in the case that our user enters value or option 1, and I'm going to add break at the end of each case, so here as well. Okay, now our second case is going to be when our user enters option 2, like this. So in that second case, we should allow our user to deposit money. So here I'm going to say cout, and then let's write out deposit amount. So we want to ask our user how much money he wants to deposit. So in order to accept the value that our user enters, I'm going to create a variable which I'm going to call deposit amount. So let's create that variable. It's going to be of type double, and it is going to be called deposit amount like this. And then I'm going to accept the value that our user enters here in my deposit amount variable like this. Okay, and now what I want to do with this deposit amount is I want to add it to my balance. So I'm going to say balance is now going to be equal to whatever my balance was previously holding plus this deposit amount like this. And then let's add break at the end as well. Okay, and then our third option, our third case is going to be when our user wants to withdraw money. So I'm going to copy this case here and then paste it here. And here I want to write out a different message to my user. So I'm going to say withdraw amount. Let's copy this. Okay, and then this variable, I'm going to call it withdraw amount like this. Okay, and then here I want to enter that withdraw amount, and what I'm going to do with my balance in that situation is going to be I want to subtract that withdraw amount from my balance, but I want to subtract that withdraw amount only in a situation where this withdraw amount is equal to or less than this balance. So I'm going to say here if withdraw, where it is, withdraw amount is less than or equal to balance like this, then I want to give that money to my user. Else, meaning if our user has requested more money than he has, I'm going to write out a message. So I'm going to say not enough money like this. Okay, and that is going to happen, so this code here is going to happen in the case that our user enters option 3, which is this one here. Okay, so now if I run my program, you can see that it asks option, and let's say that we want this first option, so this check balance, and it says that balance is 500. And if I press anything else, as you can see, my program is going to close. And that is because we haven't implemented any loop that is going to iterate this code here. So let's add that loop now. So here I'm going to say do So do while loop is the one that I want to use. And then inside my do while loop, I'm going to put all of this code here. So let's add a curly bracket, close curly bracket at the end, like this. And then I'm going to say, please do this block of code here, while, and then I want to do this code here while the option that my user has option that my user has entered is not equal to 4. And when my user enters option 4, we should stop the execution of our program. So in order for our user to know that 4 means exit, we are going to write that here in our show menu function. So here I'm going to add this fourth option, which is going to exit our program like this. Okay, now if I run this code, you can see that it says that it has this menu here, and then it asks for option. So I'm going to enter option 1, for example. Okay, and this option 1 says that balance is $500. Now let's enter this second option. Let's enter this deposit option. So I'm going to press 2, and as you can see, it says please enter deposit amount. So let's say that I want to deposit $700, for example. Okay, now if I check my balance again, so I have entered this option 1, and then I press enter, as you can see, it says that my balance is $1,200. And there's one thing that I want to do with this program, because I don't like the way that this looks. It is not really readable. So I'm going to add clear screen, so clear console command, and I'm going to add that here. So after my user chooses his option, I want to clear the console. So I'm going to say system, and then let's add CLS, which is a command that is going to clear my console, clear my window. So if I run my program again, as you can see, again, we have this menu, and then it asks us for the option. So let's say that I want to check my balance. It says that my balance is $500. Now let's try to withdraw money. Let's say that I want to withdraw money, and I want to